Alright, here we go. Hope you're enjoying your snow day. This is what we would have gone over in class tonight. The homework is a group problem set, which is attached to Unit 1 at the very bottom for 2.7. And my recommendation would be to try to meet up sometime tomorrow in your free time in groups designated by yourselves, no bigger than 5, to kind of try to punch through those. They should be very similar to these. If you get stuck on any of this, you can either email me or check your textbook, page 163 to 170. All we're going to do is use the idea of derivative in respect to economics and business functions. So we're going to look at total cost, total revenue, and total profit. Generally speaking, cost is how much it costs you to manufacture your product. Revenue is the amount of money you will take in from the sale of your product. And profit is the difference between how much you take in and how much you spent on making your product. So you're going to be given cost, revenue functions. Sometimes you have to make up your profit function by subtracting those two. And we're also going to look at the marginal cost, marginal revenue, and marginal profit. And all of those are the derivatives of cost, revenue, and profit. Basically the instantaneous rate of change of those. So marginal cost is how the amount of money it costs you to create a product is changing with respect to time at that particular point in time. So marginal cost literally is just the derivative of cost. And marginal revenue is just the derivative of revenue. And marginal profit is just the derivative of profit. So if you have the original functions, sorry about that, you just take their respective derivatives. So kind of going back, we're going to look at the fact that total cost in producing a particular number of items, the exact cost per producing the next item would be the difference between the cost of producing just a certain number and one more than that. We are going to use the idea of a derivative as the approximation of that specific exact difference. So if the total cost of producing a particular number of electric guitars is given by that function, the exact cost of producing the 51st guitar would be the cost of the 51st guitar minus the cost of the 50th guitar. And so that's a C, by the way. We would just plug 51 and 50 into our function, so it would be 1,000 plus 100 times 51 minus 0.2 times 51 squared. That's putting 51 into this function. And then we would subtract from that what we'd get when we plug 50 into this, which would be 1,000 plus 100 times 50 minus 0.25 times 50 squared. And if you went through all that rigmarole and actually calculated all of that, you would find that it would equal, sorry, I'm very bad at videoing and writing at the same time, $74.75. So what we're going to do instead is we're going to use marginal cost to approximate that cost. So we are going to find the derivative of our function, which is just our regular derivative rules. Derivative of a constant is 0. Derivative of 100x would be 100. A derivative of this, we would pop the 2 in front and multiply it and reduce by 1. So the marginal cost function would be 100 minus 0.50x. And then to find the cost of the 51st guitar is approximation, we would plug in 51 into that function, and we would get, once we crunch those numbers, $74.50. So again, it's close, not exact, but that's because it's an approximation. So the other thing we've looked at once or twice on homework problems is finding average cost. And again, just like in stats, when we put the little bar on the top, it meant the average. So the average cost would be the cost function divided by x. Remember, x is how many units you're producing, so the cost divided by how many you're manufacturing would be the average cost. Same with revenue. The revenue divided by how many you are producing would be the average revenue. Same with profit. So those are, averages. And again, we can find the derivative of each of those. Again, so you have to watch the terminology. The difference between marginal average cost and marginal cost is just the one word in there, so you've got to be careful of it. So marginal average revenue would just be the derivative of average revenue, and marginal profit would be the derivative, sorry, that's a P, of average profit. So again, as a hint, to calculate the marginal averages for each of those, you first calculate the average function by dividing the original function by x, and then take the derivative. Otherwise, it won't be beneficial at all. So that's your first page. Now we just have a series of examples to kind of put these all into place. So we have a cost function for printing an x number of dictionaries is 20,000 plus 10x. So it wants to find the average cost of per unit if 1,000 dictionaries are produced. So the first job is to find the average cost function, which is to take the cost function and divide by x. So that's how much it costs to produce dictionaries, and if I want to find the average for a particular number, I just divide by x. So that actually gives us 20,000 over x plus 10, because this x gets divided here, and when it gets divided here, those x's would cancel. Which means if I want to find what the average cost would be for 1,000 dictionaries, I'm going to plug 1,000 into here. You could plug 1,000 into this one as well and get the same answer. This one just there's less work. So 20,000 divided by 1,000 plus that 10, 20,000 divided by 1,000, plus would be 20 plus the 10. These all cancel, so it'd be 20 plus 10 would be $30 per dictionary. Sorry, cannot hold this at the same time. All right, find the marginal average cost at a production level of 1,000. So again, to find the marginal, you're looking for this keyword here is indicating I need to take the derivative of average cost. So we have our function up there for average cost. So if I want to find the marginal average cost, I need to take its derivative. So again, I would rewrite the average cost function, that's not supposed to be 3 of those in there, as 20,000x to the negative 1 plus 10. Again, that was we learned last class. When we have a variable in the denominator, we write it as a negative exponent, so that when I go to find this, the derivative drops in front, it becomes negative 20,000x to the negative 2. Derivative of a constant is 0, and there it is right there. And now I can plug in my 1,000 in here, and it would be negative 20,000 over 1,000 squared, because that just means it goes to the bottom. And if you calculate that, you would find it equals negative 0.02, again, dollars per dictionary, which means, and this is important, on your notes there's a little box. What that means is if you raise the production from 1,000 to 1,001 at that point in time, the price per book falls approximately 2 cents. So cost per dictionary is reducing by 2 cents per dictionary. So, which is nice if you're the one making the dictionaries, because as you produce more, you are spending less to make them. Use the results from above to estimate the average cost per dictionary if 1,001 dictionaries were produced. So that means if I have at 1,000 dictionaries, it's costing me $30, which is our result up there, to on average $30 per dictionary. But the rate of change of cost at that point in time is negative 0.02 cents. Then the estimate average cost at that next dictionary, I would subtract that 0.02 and get $29.98 as the estimated average cost. Again, in red, I'll try to hold this steady for you. That means the average cost per dictionary for 1,001 dictionaries would be the average for 1,000 plus the marginal average cost. In this case, that was a negative, so we're really subtracting because we're spending less on the manufacturing cost of our dictionaries. So $20.98. All right. One more example, and this has a whole bunch of stuff to it, so you can see, including a graph, and I'll show you how to do that in your graphing calculator. But notice this one's a little bit different. It's given us a price demand equation and a cost function for producing television sets. So all the price demand equation is is how much you can charge per, I guess in this case, television set for your, in essence, to create your revenue. So I'm going to show you down here in a minute for number 2 to find the revenue function. We have to take that price. So this is a small p. It is not profit. It is the price demand equation. And then this is a cost equation. So to find the marginal cost, again, hopefully we recognize that word marginal. Marginal cost is the derivative of cost. So to find the marginal cost, I just take the derivative of this function, which would be just 30. Done. It's a constant. It equals 30. And we're done there. Now to find the revenue function in terms of x. So if you think about, if p is how much I can charge, the price I can charge for each of my television sets, to find the revenue would be how much I can charge times however many of them I sell. So to find revenue, and this is going to happen, your revenue function is that price function times x. So it is not, this is a little p for price. So the revenue function is going to be 300 minus x over 30 times x. So it will equal 300x minus x squared over 30. So you might want to, again, I take the price function and all I do is multiply it by x. So each of these gets multiplied by x. So this is my revenue function. I need to find that first before I can find the marginal revenue. Again, marginal means take the derivative. So I'm just taking the derivative of this using our rules. So the 300x becomes 300 and minus 2x over 30, and 2x over 30 would reduce to x over 15. Sorry, I'm off camera a little bit there. So there you go. That's my revenue function. Now it says find the revenue, the marginal revenue at 1500 and interpret the results. So that means I just take my function we just found in number 3 and I plug in 1500. So it's going to be 300 minus 1500 over that 15. And if I do that, again, this is going to give me 100. 300 minus 100 is 200. And in context, that means when I'm making 150 televisions, each additional television that I make increases my revenue by about 200 bucks. So as I am making 1500, the instantaneous rate of change of my revenue, how much extra revenue I'm making per TV set, is 200. Now if that were negative, that's how much revenue I would, or basically how much I would be losing. Alright, so then we're going to come down here. We're given some constraints here. Graph the cost function and the revenue function on the same coordinate. Find the break-even points. So I'm going to show you, this is from a calculator, but I'm going to show you how to do this in your calculator. So this 0 to 9,000 and 0 to 700,000 are basically going to be your window. So when I go to my calculator here, I'm going to put it, because I need to put all these on here. Alright, so you hit your window button, which is right there, and X is going to be 0 to 9,000, and those are pretty big spans, so I'm going to make my increments, my scale of 500. Y min, I'm going to go 0 to 700,000, and again, those are pretty big, so I guess I'll go 100,000 for my scale. Resolution, I'm just going to keep as 1. Now it wants us to graph cost and revenue, so I'm now going to hit my y equals button. Make sure all of your plots are turned off from stats. You don't want any of those on. And then I need to put my cost function in, which is 150, 150,000 plus 30x, and then I'm going to go down to y2 and put in the revenue function, which is the one we had to find right here. So 300x minus x squared divided by 30. And then if I go to and just hit your graph, I've already done the window, so if I hit graph, it should show up as my two functions. The curved one is the one that has the